Dear viewers, welcome to the YouTube channel H2O Chemistry. I'm Satya Narayan and your chemistry teacher. See, in our YouTube channel, we learn chemistry in an easy manner and with reasons. The learning is very conceptual as well as the learning happens without any stress. So, always enjoy your learning. The subject is so simple. My dear children, today I am going to teach a concept called calculation of number of atoms or number of moles or number of molecules if you are provided with a mass or mole or volume. So for all kind of calculations which in which mole is involved, so if you know this idea, we can do wonders. We can easily solve the sums. So what is the first one? Gram atomic mass or gram molecular mass of atom or molecule respectively equals 1 mole. Equals 1 mole. Contains 6.023 in 10 to the power of 23 particles. The particles may be atoms or molecules or ions, in which if it is gas, which occupies 22.4 liters at STP. So this idea you should be very aware of. If you're aware of this concept, the remaining solving the sum will be very easy. Now come to the first example. I'm going to give one example for molecule and an atom so that you will not face any problem while calculating the number of particles. Now, oxygen molecule. So we call O2, it is a gas. So the gram molecular mass of O2 is nothing but how many number of atoms we have? 2. So 2 into atomic mass of oxygen is 16. So 32 grams of, we get it. So 32 grams of oxygen, which equals 1 mole. Just now we have seen gram molecular mass is how many moles? 1 mole. So 32 gram is a gram molecular mass of oxygen, so which is equal to 1 mole, which contains 6.023 in 10 to the power of 23 molecules of oxygen, which occupies 22.4 liters at STP. So this is what you have to understand. Now, what if I double this number? So 32 grams, if I double to 64, what do you get it? So 64 gram, just I doubled. So every number you have to double, that's all. So 64 grams of oxygen equals 1 into 2, 2 moles, contains 2 into 6.023 into the power of 23 molecules, right? So which is nothing but 12.046 into 10 to the power of 23 molecules. Am I right? So which occupies, again we have to multiply this number by 2, right? It's 2 into 22.4 liters at STP. So the answer will be 44.8 liters. So it's quite easy, right? So depending upon the number, we're going to calculate this whole idea. Now if you're provided with the mass, we can calculate number of molecules, or if you provided with number of moles, we can calculate this, or if you provided with the volume, we can calculate this. Let's go for the next one, that is atom. Helium atom, which is a gas. So the gram atomic mass of helium is 4 grams. Am I right? It's a 4 grams, and 4 grams of helium equals 1 mole, because gram atomic mass also 1 mole. So which contains 6.023 in 10 to the power of 23 helium atoms, which occupies 22.4 liters at STP. What if I half this number? So 4, half of 4 is 2. So what are you going to do? Every number we're going to divide by 2, right? So the 4 grams of helium equals 1 by 2 moles, nothing but zero point 0.5, right? So 0.5 moles, which contains 6.023 in 10 to the power of 23 divided by 2 helium atoms, right? The number will be approximately 3.0115 into 10 to the power of 23, which occupies 22.4 liters divided by 2 liters at STP. So if I divide by 2, what is the answer? 11.2 liters. at STP. So this is a value you should understand. Now based on this we will get sums, Kana, my dear children. So we will work out the sums directly. So what is the first sum, which is given in your page number 101. So 101. So refer this page number, we will work out that sum. Now, so in every calculation like this, if you are they are asking number of atoms, we have to calculate the number of moles first, because number of moles contains 6.023 into the power 23. We can easily calculate that. So first step number 1, we have to calculate number of moles, right? So how do you calculate number of moles? If volume is given, so we have seen the formula already. So the answer is, the formula will be this: given volume at STP divided by molar volume at STP. Am I right? So this is the idea you should follow, my dear children. So what is the given volume at STP? So the given volume is 11.2 liters of carbon dioxide. So 11.2 liters divided by, what is a molar volume? See, 22.4 liters is nothing but 1 mole. So this is called molar volume. So 22.4 liters. So you strike out this. Now what is the approximate value? So if you divide by 11.2 exactly, so it is 1 time, this is 2 time. So the answer is 1 by 2 liters, which is equal to 0.5 mole, of mole, otherwise 0.5 moles. So it is a mole. Now we have calculated the number of moles. So the number of moles in 11.2 liters of carbon dioxide is 0.5 moles. Now what they're asking is number of molecules. So we will calculate the number of molecules. So the number of molecules in 11.2 liters of carbon dioxide is equal to, so we know that 1 mole of any substance contains 6.023, right, in 10 to the power of 23 particles. So if you multiply the number, if you multiply the number of moles into Avogadro number, we will get the number of molecules. So what is the number of moles we have calculated? 0.5 into Avogadro number is 6.023 into 10 to the power of 23. So I'm going to change this into 1 by 2 into 6.023 into 10 to the power of 23. So if I cut this, what I get is, so 3 2 3s are 6, 0 again, 2 1s are 2, and in 3 1 I have the remaining 1. So if I add 0, 10 is okay. The value will be 3.0115 into 10 to the power of 23 molecules. So what I have calculated is this. Therefore 11.2 liters of carbon dioxide at STP contains 3.0115 into 10 to the power of 23 molecules, right? I hope this video will be very helpful, my dear children. To do this sum is very quite easy, my dear children. If you like this video, subscribe and click the bell button to get the notification very quickly. Like this video, share it to your friends. Let them learn the concepts very easily. Thank you, my dear children. See you in your next video. In our next video, the learning will be happy here. Thank you.